Hello and welcome back. It's time once again to try to fix something, and today on the workbench I have a PS5 Blu-ray edition that is supposed to be not working. Now let me give you the backstory on this one. I bought this thing back in September, and this is now late December. And I have when I got it, it was supposed to be totally dead. When I got it, I plugged it in and it turned on immediately, no issue. And actually, I installed a game and it ran for hours, no problem. And I was so surprised that I messaged the guy that I bought it from off eBay, and he goes, well, he was surprised. He said that they could not get it to work. They had tried several different cords and outlets in the house, and they took it to a local repair shop, and that repair shop couldn't get it to turn on. But somehow when it got here, it turned on, although it did. Later on that day, I came out of the garage after it had it running, and it turned itself off, and it didn't go to sleep. It turned itself off. It would not come back on. So basically, it's an intermittent, and I have been putting it off because I hate intermittents. I just hate them. So I put it back in the box, and it's been there ever since September. But it's time to try to do something with this thing. I have not tried to turn it on in about 3 months now. So we're going to see what it does. But that's the story. It's an intermittent. Okay, well, now she's not so intermittent. No power. Now, I don't know if another power supply was tried in it or not. I really don't know. The seller just said he took it to a local repair shop and they couldn't fix it. So I don't know what's going on with it, but it did turn on and run for several hours when I first got it, and then just started shutting off. And now it's in that mode now. I guess it's I have not touched this thing in months, and she does have power. So yeah, well, it's time to finally get into this thing. I've put it off long enough. Let's see what we find. Okay, like I said, I have not had this thing apart at all, but another shop did, and you can see they've kind of pinched the Wi-Fi cables in there. So that's not good. Hopefully they haven't permanently damaged those. Let me get on into it. Okay, and I do hate to see that. Right through that ribbon cable. I'm not sure if that's one of our issues right now or not. It could be, because there's going to be a supply voltage in there. Let me see if I can. Maybe I can disconnect that. And let's just see what happens if we disconnect the ribbon cable for the lights. Disconnect it. Let's just put some power in it and let's just see. I have seen that happen before for other people. Now, I haven't seen one myself yet, but all right, so that's isolated now. That it's not going to cause us any issues. There won't be any lights. Do we have eject? We still don't have eject. And we don't have power. So that's not our issue. It's not a good thing, but it's not our issue. Okay. So we keep digging. All right, we are into the main PCB here, and it's looking very clean. I don't see any signs of flux anywhere. I really can't tell if it's been worked on at all anywhere. I mean, I'm not seeing it yet. Could be on the other side of the board. But yeah, really clean. Let's just see if we have 12 volts. I'm hearing a pop when I plug that cord in there, which kind of tells me that the supply is drawing current. I don't know if it's doing anything or not, but she's drawing current. Let's see if I can do this. There and there. Oh. We have nothing. Really? Oh, no, there we go. Oh, we're making a good connection. 12 volts. So not going to be that easy. We do have power. Let me confirm she still does not turn on. Nope, not at all. Okay. So we're going to have to get this thing inside on the workbench and see if we can figure something out. I kind of prefer it just stay dead like it is. All right, we are inside the workbench, and I'm getting ready to apply power to this board from a bench power supply. Just want to see how much current it draws, and then maybe we can look through some of the standby voltages and see if there's anything missing. I think I'm connected right. You can see it's labeled on the board, positive right there. So, as long as I don't get my leads reversed over here, I'm fine. Let's enable it and see what kind of current draw we get on. Look on this left-hand panel. Wow, 3 milliamps, and that's it. That's pretty dead. On like the PS4s and 5s too, there should be like a rapid current increase, and then it settles back down to some nominal value. But that 3 milliamps and then nothing, no increase, just sits there and holds. That's pretty dead. So let me see if we can figure out. Let me get this in a holder or a tripod, and we'll see if we can chase some standby voltages. All right, we still have 12 volts applied. Make sure you can see this meter. Oh no, I don't have 12 volts applied. Let's start out by doing that. All right, now 12 volts is back on, which you should be able to see right here, no problem. 12 volts. All right, do we have, I believe this is a 5 volt standby over here. Well, that was a short trip. No 5 volt. I believe that is a standby. I think this is 12 volts coming into it. Right, and then there's a 5 volt standby here. Okay. Nothing. Let's turn off our power. 12 volts is off now. You can see that. It should be bleeding off. Let's make sure we don't have a short on that 5 volt rail. Continuity mode. So here's ground. No. Yeah. I saw it. Well, we're in continuity mode, so it goes so high. But I'll go back to resistance just so we can see what the resistance is on that 5 volt rail. We're in the mega ohms, so it's not shorted, at least not on the output. Okay, this is a new one to me, but at least I'm glad it's actually failed and is not staying intermittent. Let me go back to DC. Turn this back on. Still only drawing like 3-4 milliamps when I apply power. 12 volts in, and we're in the millivolts out. Okay, looks to be a controller IC right here that handles that. Let's take a look at that area under the microscope. Let me see if I can get that working. All right. Let me move some stuff around. Look right in that area. Okay, see a couple of healthy MOSFETs there that look like are responsible for doing this. But that's going to be the controller IC right there. It's a TI chip, looks like. It has a 3219. I'm not sure if I've got any information on that thing or not. But I can't help but think there's probably an enable that's involved in this. And maybe that enable is missing. Let me try to confirm. Maybe my information I'm looking at is wrong here. Is that supposed to be a standby voltage or is it a runtime voltage? I don't know. I don't know. All right, let me do some investigating. All right, it does look like I'm not totally crazy here. I've got this board flipped over right now. Let me, still got 12 volts applied to it, so let me be very careful. It does look like, though, This is a standby 5-volt supply. And this IC right here is responsible for generating it. And it says 3219 on it, which looks to be this IC right here, TPS 53219A, synchronous buck converter. So at least we have some information on it. I see it does have an enable line on pin 2 there. This is the diagram I'm working off of, which you can find on the internet. This says this is a standby voltage, and it should be there. And a lot of this other stuff's not going to be there until it's there. There's like a 1.9 and what did you see there? 2.8, 3.3 maybe. A lot of that's just not going to be there if this thing is not doing its job. So I'm trying to figure out, is there something missing? I know we're getting 12 volts to the circuit. Is there something missing on one of these pins going in here that's keeping it from working? Because the output doesn't seem to be shorted. So I'm going to have a look around this IC under the microscope. Maybe there's a loose connection. All right, I've been doing some digging, looking around this area. Let me get my probes. I'm trying to get where I can show you what I'm trying to do here. I'm going to enable the 12 volts. So 12 volts is on the board. Pin 2 of this IC is right here. This is 1, you see the marker. This is 2. And I'll show you the voltage. Well, if I get out of resistance mode, I'll show you the voltage. There we go, maybe a little bit better. Right in there. Right here. That's the enable signal into this chip. And we're varying around so much. You see how nervous that thing is? And according to the specs in this data sheet, about 1.7, 1.8 is a valid enable signal. And let me show you. Let me draw this out to illustrate what the heck I think is happening. But if you look right here, that's 12 volts. Now if I get on the probe, see? 12 volts right there on that resistor. You've got a divider here of some kind. Look, 12 volts coming in here, through here. There's a capacitor to ground, resistor here, another resistor here. I don't see anything else unless there's something under one of these resistor pads. It looks like it's just the 12 volts. It looks like it should just enable itself. I did check right here, resistance to ground, and this measured like 17, 18 k ohms. So there's not like there's a short like this. I don't think that capacitor shorted, but it acts almost like one of these resistors has changed values or something. Something weird happening, because, so right there, that voltage is just so nervous. I mean, so I don't have another board to compare to know what those resistors should be. They look fine, but I'm going to see if I can get a measurement on those things. Let me just turn off this power supply. Okay, maybe we'll go to resistance mode here. I'm not sure how well we're going to be able to do this in circuit, but we'll give it a try. What about this one right here? 20 k ohms and climbing. What about this one right here? 15 k ohms. And this one right here, 28 k ohms, roughly. So we've got a divider there, and the data sheet does mention if the enable signal is going to be more than 5.5 volts to put a 1K resistor in series. So they want to limit that voltage, but they want it to be at least like 1.8 volts. So unless there's something else in this circuit that I have not seen yet, there's something going on here. Is it the IC itself holding down the enable line? That's a possibility. The only thing I can think of to do now would be to flip these resistors around, so that we can get a good reading on them. Basically lift one end of them. Leave them in place, but just spin them around. That way I can't lose track of them. And let's see if we can get a good reading on them. I'm still not going to know if it's right or not, but I mean, with simple Ohm's law, we can figure out what the voltage should be going through those three resistors, starting out at 12 volts. We can do the math and figure that out, and just see if it looks reasonable. All right, I have sketched out the basic circuit there. Looks like a 220K, and then an 18 and a 47K. And if you work out the current draw, it should give you a voltage of like 2.74 volts into that enable line, assuming that it's a relatively high impedance. I just checked with my meter; it measured like 9.7 megohms. So the resistors look good. That adds up. That should be more than sufficient to enable that chip. That capacitor is the one unknown because I managed to break it when trying to check it. It seemed to measure about 850 nanofarad, which I'm guessing it was probably like a 1 microfarad. But was it leaky? Because that could explain the odd behavior. So I think what I'm going to do now is put these resistors back in place. Just spin them back around and leave the capacitor out. And let's see what voltage we're getting then. All right, our resistors are back in place. I left the capacitor off. Let me get, my supply and leads are still hooked up. It's not enabled yet. I was letting it cool off a little. My hot air station is still trying to cool off. Let me enable this. Oh, we went over 300 milliamps. Off the current draw off the 12 volt supply went way up. So I think we have done some good here. Oops, I think I have knocked my meter out of viewing. All right, let's look and see what is this enable voltage now. 2.869. Okay. And we should have 5 volts right up here on this coil. Let me zoom back out. Right up here should be 5 volts. And it is. I do believe that capacitor was leaking. It hadn't totally shorted, but I think it was breaking down. And I think I'm going to replace it with, I don't know, a 0.1 would work. Let me see if I've got a 1 microfarad. It'll work without it, but let me see if I've got like a 1 microfarad that will go right on there. But I think this thing's going to work now. I think she's going to work, because I just watching that current draw, it went way over 300 milliamps off, being drawn off my bench supply. So that's definitely good news. All right, let me see if I've got a capacitor, and I'll pop one on there, and we'll be ready to test this thing out. All right, we are back out in the garage, and I think I've got this PS5 put back together enough to test. Don't have the Blu-ray connected, but I don't think the Blu-ray was an issue. Yeah, I think we have enough cables. The ribbon cable's hooked up for the buttons. Let's see what happens. Yeah. We have fan spin, we have lights, we have a logo. All right, hopefully this intermittent nightmare is over. I hate intermittent. That capacitor, that's just something to, you have to keep in mind. Capacitors or components don't always just outright die. Sometimes they kind of, go a little squirrely. They go weird. They break down. They do weird things, and that's what that capacitor had done. It was leaking. But anyway, I hope that was somewhat entertaining or educational. It was for me. I feel very lucky on this one to have found that capacitor. If it was helpful to you in any way, please give me a thumbs up, and I will see you in the next repair. So long for now.